welcome to episode 13 of the Critical Coach podcast. If you want to support me, that's easy. Just grab some of my content, whether that's this podcast or something for the website, and share it around on social media. If you enjoy the podcast itself, follow it on Spotify, subscribe on YouTube, or give it 5 stars on Apple Podcasts. In this episode, I'm back talking to William Bindley, a student of and tutor for philosophy and mathematics. This is part 2 of our conversation on philosophy of science. In part 1, we talked about how science should be done. Now we're looking at the question, what is science for? Now, I naively assumed that we'd be talking about the tension between science for the sake of understanding reality and understanding reality for the sake of change, or in the words of Karl Marx, that the point is not merely to understand the world, but to change it. And I couldn't have been more wrong in my assumption. The philosophical question, what is science for, deals with something much more fundamental. What aspects of reality can science study? The answer to this question splits into 3 main camps: scientific realism, anti-realism, and structural realism, which are the main focus of our discussion. Now, before I shut up and get on with the show, let me make a couple of disclaimers. First, this conversation was intellectually exhausting. Seriously, when we finished, I had a nap and went to bed early, but it was fascinating. If, like me, you're new to the subject, take your time. Don't be afraid to take a break and come back to it. Second, our conversation got cut off partway through by a blackout. We continued the next day, but there will be a moment in the audio where things stop, we reacquire our bearings and continue the conversation. If you want to see more from William, check out his YouTube channel, which has a range of videos about philosophy and mathematics. You'll find a link to it in the episode's description. Cheers. Last time we went from, I think it was like Plato through Descartes and got to Karl Popper and Thomas Kuhn. And that was how should science be done, right? That was like the first of the 2 questions that really characterize philosophy of science. Did we get to the end of the first question?
I think there's certainly enough there for people to go and read more, starting with like a good basis. They can dig into the literature. They can watch, like YouTube videos from, there's a lot of philosophers now sort of making YouTube videos. It's not just sort of like people in their basement or something, people who study this stuff, and, not be too washed out to sea by the philosophical jargon and the concepts going on there. There are a few things I would like to maybe correct about the last one for your listeners, if you don't mind. When I re-listened to the first one we did, I don't remember the specifics, but I remember the way I introduced Francis Bacon, or it might have been David Hume, made it sound like they lived close to the time of Einstein. I said, after these people, then you get Einstein. And it's like, Einstein's well after both of them. Yeah. So David Hume, the one who gave us the problem of induction, gave us a lot of other stuff. And Francis Bacon being the first guy that we know of that ever explicitly talked about a scientific method. So they are well before Einstein. David Hume is he's the 1700s, and Francis Bacon is the 1500s and 1600s. He's born sort of midway through the 1500s and dies in the early 1600s. So yeah, I just when I listened to it, I thought, if I wanted to make this guy sound like an idiot, as in me, I would have pointed that out, sort of thing. So I was like, just wanted to clear that up.
Okay, cool. Are there any other corrections we need to go over?
No, I'd also like to tell them that I didn't think that. That's just me speaking sloppily. It's like, that's me not putting my sentences together well.
So You reckon we're good with the first question? Now we can go on to the really difficult one?
I think so.
Okay, so let's go on to the second question. Do you want to set that up?
Yeah. So the second question I loosely described in the previous one, I think, as the previous podcast, as like, what's science for? And I think that's that's how you put it in your introduction in the first podcast as well. So this one seems, I can imagine that for people who are just enthusiasts of philosophy of science and are unfamiliar with this topic, kind of seems like a silly question. Like, look at what it does. Look at how much human flourishing is a result of scientific progress and everything. Like, and the question is actually deceptively complex, and I'd like to sort of explain it by painting an analogy. Now, imagine that you could be like a god or a demigod. So, basically, you're just like a regular human being, except you are super intelligent, right? And you're very scientifically minded. You're not sort of as some faiths describe their deities as being like omniscient, all-knowing, or anything like that. You've just got this selective knowledge to do with science. And imagine that what your extremely powerful intellect, what's so powerful about your intellect is that if you know all of the conditions of the universe, the initial conditions at some given time, you could know exactly what was going to happen next. You could make every prediction successfully. So at one time t to the next moment t plus something. So long as you know all of the physical conditions that are instantiated at time t, you can tell anyone what's going to happen with respect to any physical set of circumstances. It's like you have a crystal ball, but there's no magic at play. It's all backed by rigorous scientific theory and laws and that kind of thing. So to sum it up, you're perfect at prediction, scientific prediction. Now, let's imagine another kind of demigod that's just like this. I haven't heard this analogy somewhere. It's just I thought about it this morning. Like, how would I motivate this question, which seems so trivial and kind of silly to sort of people who haven't spent a long time reading about it or might be unfamiliar with it. Hopefully this analogy is good. But let's imagine the same kind of demigod, but his intellect is different. So, her intellect is different. This demigod can't tell you what's going to happen next. You could give this person all of the initial conditions at any given time. Maybe he can predict some things successfully, a lot of things he can't predict successfully. But whatever happens at any given moment in time, this individual can explain to you why it occurs. It's a difference between what and why. The first individual can tell you what's going to happen next, doesn't necessarily know why. Okay. You can tell you, well, that thing's going to fall. It's going to break on the ground just like this. There's going to be a storm in this place. You're going to see these kind of meteorological conditions lead to these kind of weather events and all that kind of stuff. Doesn't know why. But the second demigod can't give you anything like this kind of predictive success, but can tell you why everything happens, and the explanations that this person offers are true. So the question, what is science for? When I say that, what I really mean is, should science aim to make us like the first individual in that analogy, where we just have this amazing predictive success? Or should science aim to make us like the latter individual in that analogy, where we can explain every phenomena that we encounter? We might, and a lot of people will say, like in one of our discussions earlier, you said something like you can't have both. I'd like to point something out that's pertinent here. Is I find a lot of people's initial reaction is like, why can't it be both? And I think about those taco ads. It's a soft shell or hard shell taco.
Yeah.
So for anyone who sort of doesn't know these ads, maybe I don't know if this is an Australian ad or what. So maybe you got listeners that have never seen this ad. There's like a family that argues over whether at dinner they're going to have soft or hard shell tacos when they're having tacos for dinner. And it's a furious debate. There's a little girl who says, why can't we have both? And they love her for it. They've solved the problems. They throw her up in the air. It's a celebration. I don't think she deserves that admiration. Okay. I don't think she solved anything. Okay. Because if the question was, what should we have at dinner? Should we have hard or soft? What should we serve? I guess she solved the question. But if the question was, which kind of taco shell is better, that didn't solve the question.
Yeah,
and
so it's kind of like splitting the difference.
Both. Yes, you can't actually have both when you eat a taco. You can eat a soft shell taco or a hard shell taco. You can eat one and then the other. You can put a soft shell inside a hard shell and say that, Billy, I got you, I'm having both. But the experience you have is the experience of biting into a hard shell.
Yeah.
Yeah. So there is often a kind of knee-jerk reaction. It's not altogether sort of like a flawed reaction to have or anything like that. But often when people are faced with two competing views that seem to be, that are at odds, and it's very difficult it seems like when you pick one or the other, you're going to have problems to deal with. And it seems like both have claims that are difficult not to accept. So you don't want to flat out reject one, because then there go a bunch of claims that it seems ridiculous to reject. And so both of these views appear like that, but both have problems that seem ridiculous to accept. It seems very much like a deadlock. Often the response is to say, well, why can't we have both? And the reason is that if you try to have both, let's say you craft a solution to a problem that's kind of like the middle ground between two competing views. Now, both views are going to have pros and cons. They're going to have good parts, bad parts. Let's say they're, you might think that you're getting the best of both worlds when you do this, but you're also getting the worst of both worlds, because if the first position has X many problems and the second position has Y many problems, well, if you try to put the two positions together to get the best of both worlds, you run the risk of inheriting X plus Y many problems. And I'd just like to offer that to people who say, why can't we have both? That's something to think about. There's going to be a lot of problems in each of these views that we discuss. There are two views in this debate. As people can probably guess, one view is that we should be more like the first individual in my analogy. We should aim for predictive success in science. That should be our priority. It's not going to be clear, I think, for a while, why the two are in tension, why you can't accommodate, both equally and pursue both of them. But hopefully I'll be able to make that clear later on. Please remind me if I don't. And stop me at any time, by the way. And obviously the other view is going to be that, no, what we want is to explain the universe. We want to understand everything around us. There is a tension between these two desires.
Yeah, I would have thought in order to have one, like if you wanted to be able to predict what would happen in the future, that some capacity to understand why things had happened in the past would be necessary. Like, if you're teaching someone maths, you normally do it by showing them a solved problem and saying, this is how you get from the question to the answer. You understand the process and the mechanisms working behind the scenes. Now I'm going to give you a new problem. Let's see how well you could do with that. Does that? It's confusing to me why they would be, like you said, it is confusing why they would be in tension. I would have thought you'd really need one to have any hope of being successful in the other.
Yeah.
But you probably couldn't do both at the same time. You'd have to do one and then, see how well that, if you're trying to predict the future, you would, collect information on why things had happened in the past and then use that to generate a working hypothesis of how this is actually functioning, and then go, all right, how well does that model predict the future?
Yeah, and there's certainly some appeal in the idea that if you understood why everything was the way it was and why it happened, you could tell what was going to happen next, and vice versa. Now, in the case of mathematics, I think it, like, you're right about understanding why things are the case in mathematics is going to enable you to predict how mathematical objects are going to behave. For instance,
if you can understand why 2 + 2 = 4, you can predict what the the sum of 5 + 2.
Yep. Yeah. And with the case in mathematics, sometimes I describe this as the feeling of cheating. I kind of feel like mathematicians have the liberty to cheat because they can postulate axioms from which they can prove things and things like that. And if the axioms don't seem to, if we find that a set of axioms together entail a contradiction, we can choose to reject some axioms and not. But with the case with scientists, there's these laws of nature out there, and they are what they are. And you can kind of make mathematics play ball the way you want. Scientists don't have that luxury. So, for instance, if we find that we've got this huge paradox in mathematics, and we find that it is because of some axiom that we accepted, we can say, well, that axiom's wrong. Right. And I know this sounds like Popperian hypothetico-deductivism, and just we can reject a hypothesis or something like that. But there is a sort of an intuitive view among working scientists and even among non-scientists that the laws of nature just are what they are, and the only question is whether or not we identify them correctly. You see, that view is not necessarily the case in mathematics. There are mathematicians who think that the truths of mathematics are what they are, and we go and discover them, and we invent nothing when we're doing mathematics. So, whereas there are mathematicians who think that that's not necessarily the case, this is a continuum of views. Some mathematicians will say, like, it's all invented, and some will say, no, this feature of mathematics is invented and this kind of feature is not. But it does seem that we have the luxury to tweak the thing to our liking, and mathematics is going to behave the way we want, so long as we accept the correct axioms. The physical universe isn't going to behave the way we necessarily want it to, just by choosing some laws to reject or alter and things like that, right?
Is this just just because of not just the complexity of the world outside of, just pure math, but the complexity and I guess like the variability as well. And I mean like change and just the quantity of variables that you're having to, it's not going to be a proof. Proof that you get for something like biology is not going to be proof to the same standard it might be in something like maths. It's always going to be, a best guess at what the natural laws are.
That is a factor, but what I mean is that if we imagine a world in which there's a bunch of knobs and we can sort of turn the knobs and pull levers and things like that to make it behave more or less the way we want, physicists don't have that scenario with respect to the world that they study, whereas mathematicians kind of do have that scenario.
Yeah. Because I guess, in math, I mean, it's all like, math, even for, physicists, the language used to describe physics is invented, but what it's describing is real. And I guess, math can be used to describe things that are real, but the language of mathematics, I can't think of a better word for it than language. The language itself is invented. Like you could, it could look different, but it would still be, the logic of it would still be the same if you're using it to describe the real world.
Yep. I should name the two views now. And in a sense, it would be a mistake on my part to really call them both views. They are collections of views. Both of these labels I'm about to introduce are umbrella terms for a collection of views. So it's difficult to sum them up, with a few sentences, but that's what I'm going to try and do.
Do it anyway.
Yeah. I think if I have some friends who listen to this, they might contact me and debate me on something, or don't. If you're really interested, don't take my word for everything. So one view is scientific realism. Okay, I'm going to call it a view. It's a family of views, just for ease of speaking. And scientific realism is the one that's probably going to be most appealing to people being introduced to this debate in philosophy of science. And it's basically the view that the theoretical entities in our scientific theories exist. What our best science says about the world is literally true. So theoretical entities in the literature, it's often used interchangeably with unobservable entities. So by theoretical entities or unobservable entities, I have in mind things like gravity, force, even particles. Now, like electrons and photons and things like that. Now, I know immediately a natural response is to say, hang on, we observe, particles, we have sort of electron microscopes and things like that. Well, the thing is, what we really observe are the kind of evidence that we associate with there being particles. With there being particles, like we observe things like dust chambers and things like that, and what we do is we say what explains these observations is the fact that a particle was here. So we really make observations that in order to explain, we postulate the existence of particles and things like that. And if someone isn't happy with me using particle as an example, there are countless other theoretical entities to point to in science that you could take as an example of an unobservable entity. Now, what scientific realists say is that we should literally believe in those kind of entities. And actual scientists, some of them are scientific realists, some of them aren't. I find you tend to find more scientific realists in certain fields of science and less in others. The other view is, yeah, I know, it sounds like this is the common sense view. It's like, what are like people proposing scientific hypotheses that they don't actually think literally describes the universe. And the other view is, it's a collection of views, anti-realism. Now, there's heaps of views that could be described as an anti-realist view. There was logical positivism or logical empiricism. There was scientific instrumentalism. Constructive empiricism is probably the most modern one and the one that most people think is a challenge to scientific realism. But all of these views you can kind of group together under the term anti-realism, scientific anti-realism. Now, anti-realism is the view that the theoretical content of scientific theories, or the unobservable entities or theoretical entities that scientific theories talk about, we don't have to literally believe in them. When we're proposing scientific hypotheses, or when we are referring to a scientific theory or something like that, this does not have to entail a literal belief in the existence of the entities. So you don't have to literally believe in an entity like force or something. You don't have to literally believe in sort of electrons or quarks and things like that. Now, this is probably this is probably a surprising view.
Yeah, I'm sort of wondering, if you, if you're on the anti-realism side, what does that perspective mean? If you're, if you don't believe in do they not believe in the literal existence, or is it a case of I don't know that it exists, but I act as if it does?
So some anti-realists are just flat out atheists about theoretical entities, and some are that's pretty extreme. But most anti-realists are agnostics. So basically, what you described is I don't know whether these things really exist, but I'm going to act as if they do. And that the question you raise has to be answered if anti-realists want to propose a view like this, because of course, if you're saying that good science doesn't necessitate a literal belief in the entities postulated by these scientific theories, I mean, you can say well, what did the words even mean then? What do words like quark mean? And
it seems like you couldn't. It seems like it's like, I don't know, maybe like a lack of consilience is the term. You read a paper about quantum mechanics and you're like, yep, I think this is accurate, but I don't believe in their literal existence. It is like a lot of dissonance.
Yes, and I've found whenever I make friends with a scientist, I've asked every person that I know that works in science, including someone that works on the Human Genome Project, and what's surprising to me, sometimes you get a scientist that will be like, what's scientific realism and anti-realism? As soon as you explain it to them, they know what you're talking about. They just heard it under different terms because philosophers use wacky terms. But I often find that it's pretty split up the middle, which side they fall on.
Is that within disciplines or between disciplines?
It's not fine-grained, right? I do find there's more scientific realists in some areas, and my experience should not be taken as anything more general. It's a small sample, and yeah, the more scientific realists in some areas, more scientific anti-realists in other areas, it seems. And but what is surprising to me is that they're always pretty firm. So, for instance, if you some of my friends, they'll say, "Oh, scientific realism, of course. How could you be an anti-realist?" And other scientists that I've spoken to will say, "Oh, an anti-realist. How on earth could you be scientific realist?"
So
And,
what argument do they put forward to support why they believe one over the other? I mean, I think from my side, the realist side of it seems like probably the easiest argument to make, at least on the face of it. The anti-realist argument, is it? How do they justify their position?
Yeah. Well, firstly, I'll say something about what these entities are in the minds of anti-realists, and that'll make it a bit clearer how they go about justifying it. What they do is they assign a practical role to these entities. So, insofar as postulating them or talking about them enables predictive success, right? For the anti-realist, theoretical content in scientific theories, just plug my charger in, is kind of like a computer's user manual, for instance. Maybe you go to the store and you buy a computer and it comes with a user's guide. And what you get from that user's guide is just a set of instructions that enable you to successfully operate the computer. What you're not going to get, and what you wouldn't want if all you wanted was to use the thing successfully, was a treatise on Turing machines or binary code, anything to do with theoretical computer science.
Yeah, it's like, I don't need to understand, I don't need to be a mechanic in order to know how to drive a car.
Exactly. Yep. So they want to use science to make successful predictions. And, there's a lot of benefit to that. And you don't necessarily need to understand the unobservable furniture of the universe, so to speak, to be able to do this. So,
would gravity be an example of that, where it's not what I think it was gravity, what gives gravity its mass maybe isn't known, but despite that gap in our knowledge, we can still use it to, an understanding of gravity's, the effects of it, even if we don't understand what all the working parts are, we can still use that to predict, how quickly something's going to fall to the ground.
Yes. So with gravity, we don't know what any forces are, and the current physics doesn't actually identify gravity as a force, even though physicists will describe it as a force. They're kind of just speaking loosely. No sort of physicist today thinks gravity is a force, and it's just curvature. That's kind of what gravity comes down to. It's curvature in space-time due to the presence of matter. That's if Einstein's theories of relativity are correct. And you wouldn't describe, the curvature on a ball or something like a force, right? So often in textbooks, gravity is described as what's called an inertial force, where inertia is not really a force; it's something's natural state. Whether it's moving or whether it's stationary, or sometimes they call it a fictitious force, right? Now, for an anti-realist, a word gravity is just kind of it's something that you put into your theory to help you make successful predictions. It doesn't actually matter whether gravity is the curvature in space-time due to the presence of matter. But if treating it that way helps you correct time zones on computers with satellites, and it helps GPS work properly, it helps you predict how quickly something's going to fall to the ground and all that kind of stuff, then that's all that matters as far as any talk of gravity is concerned. A realist is going to completely disagree and say, no, there is actually something, what the scientific theory should be taken to mean is that there is actually something that is curvature in space-time due to the presence of matter. And that's what we mean by gravity. I know it's a lot to swallow. Hey, scientific realism is quite
It's...
Especially the I find anti-realism gets a lot of resistance when people hear about it.
I'm trying to, understand it by comparing it to sort of other things I'm familiar with. And it's, have you heard the phrase literally false, metaphorically true?
Mm-hmm.
So I wonder whether anti-realism is a case of, I'm okay with being literally false as long as I'm metaphorically true. Like, porcupines, people think porcupines can throw their quills. They can't. But if you act as if they can, you get a whole bunch of residual benefits from that belief. So like in the last podcast, you were talking about, the difference between Newtonian gravity and Einstein's gravity, and the fact that NASA still uses, like, I guess, Newtonian equations for some of the stuff they do, even though it's it doesn't actually conform to what Einstein's saying about gravity, but it's a good enough user manual that it's still going to solve problems for you, even though it might be literally incorrect. It's a close enough approximation that you can still be productive with that knowledge.
Yeah, I think that's analogous to anti-realism, because what NASA's doing there is using physics that our best current science says doesn't describe how the universe actually is. But if you treated it as true, you could make successful predictions about how much escape velocity a rocket needs to get out of the Earth's gravitational pull, which is a word I use, that would only make sense in a Newtonian context. Because in an Einsteinian context, there's no such thing as nothing pulls. There's this invisible hand coming out of the Earth to try and pull things back down towards the surface. I think that's an example of people kind of acting in an anti-realist spirit for practical reasons. But that doesn't necessarily mean that the people doing that have an anti-realist position. It's just that if you were to use the more complex physics and equations of Einstein's theories, it's not going to buy you anything extra. You're going to take on board a bunch of complexity for no gain. It's work for nothing.
Yeah, that makes sense.
Yeah.
But you might need that complexity for, other problems. Like it might be apt for, solving some problems, but for other ones, you will, you might need that complexity in order to, do anything with that problem.
Definitely. Yep. Yeah. I mean, for instance, NASA sends up satellites and things like that. Closer to the Earth, further away from the Earth, time is different. Time moves faster and slower depending on how close or far you are from a large mass. And in order to keep the world's clocks synchronized, it's Einstein's more complicated physics and his more complicated equations that allow us to, that would allow someone in one country to see, a time that if you were to add or subtract the right number of hours and minutes to know what time it was in some other place, you would get the right answer. If
we like the one about GPS satellites and lack of time synchronization between what was on Earth and what was orbiting the planet because of how I don't know, is it speed or gravity that affects time? But you know, they were always out of sync. How would how does realism and anti-realism affect that problem?
Yep.
Would one be better at solving it or recognizing it before it was a problem, you know, that they had to fix after the fact?
There's nothing you can say about either of the two views that would place one in a better position. You know, some people, some philosophers think it doesn't make a difference whether all scientists and all scientists were anti-realists or all scientists were anti-realists. I don't know whether I said anti-realism twice or realism twice or whatever. But you know, some people think that you're going to get the same science either way. So it's just a matter of sort of intellectual interest. What happens to be the case, you know, and many don't. So sort of like my short answer to that question is it's sort of a matter of controversy. One thing to take into account is that I would imagine, I'm pretty hesitant to ever sort of give my own personal views. I don't want to ever bias anyone's thinking. I'm very clear, very careful not to do this whenever I'm tutoring. But I would imagine that if the world was made up of, you know, if all scientists in the world were anti-realists, you're going to see them proposing different kind of hypotheses than you would.
That's what I'm wondering. Like, what are the consequences of buying into one versus the other? Does it change fundamentally how you approach the process of science, or, you know, your consideration of, you know, the outcomes of scientific experiment? You know, does believing in one or the other change the way you behave as a scientist? Or is it, you know, largely, you know, academic, and, you know, whether you're a mechanic or not, you still drive a car the same way?
I think there are some things about process that aren't going to change, whichever side you fall on. So, for instance, if we just imagine that everyone is being preparing in their process, proposing hypotheses and then trying to falsify them, like Popper thinks we should, that process is going to work the same way. But the thing is, what changes in this scenario, and depends on whether you're an anti-realist or a realist, is not whether is not the process. It's what you're putting into it. So it's like the hypotheses that get put into the process are going to be ones that postulate entities in order to facilitate successful predictions. And on the other hand, you might get hypotheses that get put into the process in order to test whether statements that make claims to explain why the universe behaves the way it does or is the way it does are true or not. Yeah.
So it's like going back to the analogy you used at the start, is that one is focused on, you know, figuring out what will happen in the future, and the other is looking at why things happened in the past.
Yeah. So, you know, the consequence is that if you take, you know, let's say like everyone took an anti-realist position, that means science is going to head towards the direction of the first sort of demigod I described, that can tell you what's going to happen next, so long as the individual knows all of the present conditions, right? Whereas if everyone was to take a realist position, then it would seem, at least, that science is going to head in the direction of the second demigod, the one that can't necessarily predict what's going to happen, but knows why everything happens. Now, that kind of predictive success needs to be qualified. Okay, what I mean by that is that not all predictive success is the same. Okay, so anti-realists, when they talk about predictive success, and they call it empirically adequate, or empirical adequacy. So if if a theory generates predictive success, they call it empirically adequate. And they say all you need, all good science needs is to be empirically adequate. Now, not all predictive success is equal in merit, because when you have, let's say you have a scientific theory that's being replaced. Let's just take Newton and Einstein to stay consistent with our historical examples. There's a lot of predictions, incredible amount of predictions that Newton's physics successfully predicts. So Newton's physics is, as anti-realists would say, empirically adequate on a great number of physical phenomena that can be observed. Now, when you transition to a new theory, let's say we're taking Einstein's physics, Einstein's theories of relativity, there has to be a carryover of what was successful, right? And then everything that's not carried over is new in Einstein's theories and used to predict other things that we haven't yet predicted. So this amount of predictive success that's carried over is not what would be called novel predictive success, right?
By novel, you mean new?
Yeah, right. New, and also stuff that we would have absolutely no reason to expect to happen if we didn't have the new theory. So it has to be new, and it has to be something that's very risky. So for instance, if I was, suppose I tell you I've got a theory that helps me predict the winners of US presidential elections. And, let's say I pick one of them and then that person wins. You wouldn't really be convinced that my theory was all that good.
Yeah. Someone
had to win.
You had a 50-50 chance of guessing right anyway.
Yeah, exactly, right? But suppose I could tell you with some quite impressive degree of accuracy how the vote count was split up.
Yeah, that would be impressive. It would be concerning about voter fraud,
yes.
But yeah,
it would. Yeah. So, if I could convince you not to sort of report me to the authorities, you would think that, if I could convince you that this theory was good, and let's suppose I could replicate it in a few successive elections, you'd call this novel predictive success. And one of the properties that it has that makes it novel, it's not the sort of the distinguishing characteristics, but one of the things about it is that I could have been so easily wrong. There's so many ways that vote count could have turned out.
Call.
Yeah, exactly. It's bold, right?
Yeah. So it's incredibly right and incredibly early and unlikely.
Yes. Yeah. So, for instance, there are some measurements and predictions that are very novel and very successful in quantum mechanics, where the degree of accuracy in which they predict some phenomena is accurate to like measuring the distance between two world cities like New York and London with an accuracy that's like an error margin that's the width of a human hair, right? So that kind of stuff makes what I'm talking about with the election results, as shocking as that would be if I could predict that. Things are happening in science that kind of piss on that, right? You know what I mean?
Yeah.
I mean, there is the difficult factor that you're talking about human psychology, and it's not very well understood. And there's no science of predicting election results. But
I'm trying to remember the guy from the Middle East who very close to being accurately predicted the size of the Earth's surface. and it would have been like 1,000, 1,500. It was a long time ago.
It's like ancient Greece.
Yeah, I thought the guy might have come from the Arab world, but I might be wrong.
Mm-hmm.
But he was basically, I think he was, measuring the time it took the sun to transit between two points of a known distance, and from that, tried to predict the circumference of the Earth, and was incredibly accurate. Like, he didn't get it bang on, but it was close enough that you think, wow, for someone, so long ago, to make, and when, now, the advanced understanding of mathematics, you're like, yeah, I can tell you exactly why that would give you a fairly good approximation of the Earth's circumference. But then that would be, it's a prediction so bold that you wouldn't be able to confirm it until, relatively recent history.
Yeah, I'm kind of like upset with myself because I'm familiar with this. I'm familiar with this, and the guy's name escapes me. And I thought it might have been Thales, but I think Thales did the prediction with the pyramids, and people often describe him as an ancient Greek, but he was actually from modern day Turkey. So
I'm just Googling now, trying to find it.
I don't think it was Thales.
Okay, so this looks like a similar story. Hopefully it's not going to play this video. The name, that's a whopper. Eratosthenes or Eratosthenes or something like that. But over 2,000 years earlier in ancient Greece, a man arrived at nearly the same figure by putting a stick on the ground. That man was Eratosthenes, I don't know, it's a big one, a Greek mathematician and the head of the library at Alexandria. Just which Alexandria that was, I'm not sure. In the mid-20th century, we began launching satellites into space, and predicting that the Earth's circumference is 40,030 kilometers. But over 2,000 years ago, earlier in ancient Greece, a man arrived at that exact same figure by putting a stick in the ground. So it sounds like he was a Greek.
Greece meant a lot of places back then.
Yeah.
So you could be talking about modern day Turks, Egyptians, what we nowadays call Greeks, and Yeah,
I'm trying to find Syene. I'm not sure. It's spelled Syene. And my computer's shitting the bed. Egypt. Yeah. Aswan is the ancient city of Swanet, later known as Syene, which in antiquity was the frontier town of ancient Egypt facing the south. So it looks like, that's quite confusing. So that's probably why I thought the guy was an Arab, because of the location, but with a name like that, it sounds very Greek to me.
But
anyway, I'm getting distracted.
No, it's fine. It's a bold prediction, right? So an anti-realist would say that ancient mathematician's prediction was empirically adequate when we did those measurements with the satellites and found the figure to be exactly what he calculated by placing a stick in the ground and doing some geometrical reasoning. Now, there are two arguments in favor of both of the views. So you asked about this a while ago, and we only just got to it now. And this will because what we haven't, I think what I haven't done a good job of yet is explaining why anti-realism would be attractive to anyone. And hopefully this will go some ways to explaining that. But we have on the one hand the no miracles argument. There's like many versions of it that have been put forward by different philosophers, often abbreviated NMA. And the most famous way, the most famous version of the no miracles argument, I think, came from a philosopher named Hilary Putnam, and it's an argument in favor of scientific realism. And then on the other hand, you have what's called the pessimistic meta-induction argument. And that's the most famous argument in favor of anti-realism. And some philosophers take one of the arguments and reject the other. But many kind of feel like they're both very convincing, that there's like a deadlock between them, an impasse. And I'll probably, I definitely should explain the two. So the no miracles argument is probably easier to explain, but it appears in different forms. It is like a version. So, for instance, our best scientific theories are remarkably successful. Now, if our best theories weren't true, their success would be miraculous.
Yeah, that makes sense.
Like it would just be a miracle. Now, the next premise would be to do with not accepting miracles. We shouldn't accept miracles. When there's all these other things we might point to in order to explain the success of science, it would be silly to say miracles. Whatever someone might have in mind by the term miracle. So hence the best explanation, this would be the conclusion of the argument, is that scientific theories are true. Now, remind me, please, to talk about scientific truth at some point if I forget. I don't think I'll forget, but we're going to have to come back to this notion of truth. Yes.
I've got two reminders here. One is to clarify the tension between the what and the why, or the realist and anti-realist. And
yes.
What was this one? Scientific truth.
Yes. So right now we're making headway with the first thing on your list, and the best explanation for the success would be if the theories were approximately true. Okay. Now, at first glance, it's pretty convincing. I remember thinking to myself that I couldn't imagine how this argument could be faulty. But there's a lot that can be said in criticism of both arguments, including this one. Now, if you look at the history of science, there is a huge number of scientific theories that have been rejected that were once in good standing and had consensus within the scientific community. And all of these scientific theories made reference to theoretical entities. So, with the rejection of these theories in favor of new ones that were more successful, often what happened was also the rejection of the theoretical entities, or some of the theoretical entities that were proposed in the theories that were rejected. So, in other words, some theoretical entities don't survive theory change. For instance, we used to think that we used to postulate this substance called phlogiston to explain combustion. And when we realized the phlogiston theory of combustion was wrong, no one believed in phlogiston anymore. It was a theoretical entity. Then there was the caloric theory of heat, and caloric was a theoretical entity. We don't believe in that anymore. And with that, caloric died as well. It didn't survive theory change. And nowadays, our theories of heat make reference to the motion of particles. These particles are like moving really fast, and you get this heat energy, and it gets transferred from one side. And if you get enough of that, you can get combustion. So there's reference to theoretical entities again to explain empirical observations. Now, it would be pretty lucky if the theories we have now and the theories that we talk about now, the theories we have now and the theoretical entities that are that appear in those theories now are the actual correct ones that explain the physical phenomena, that these ones aren't going to be replaced in the future and join the dead in that mass graveyard of theoretical entities that once enjoyed good standing. That's also difficult to think as well.
Yeah, because it just seems unlikely based on what's come before.
Yeah, exactly. So that's actually in a rough way what the pessimistic meta-induction argument is. It's in favor of anti-realism. It's saying the no miracles argument was
that the whatever theoretical entities you're proposing are somewhat arbitrary, maybe.
Not arbitrary, because they get postulated if you're a realist, they get postulated because you think that's the way the world is. You postulate them because you think they exist. And if you're an anti-realist, you postulate them because you think they enable successful predictions. So I wouldn't say arbitrary, but it's like being a detective trying to find a murderer. And let's say you have this track record of developing this profile for what you think the murderer must be like, or let's say going through suspects. You've gone through so many suspects where you're sure this was the one who did it, and you find out that the person couldn't have been the one who committed the murder. What the pessimistic meta-induction is saying is that if you were a detective in that scenario and this murder is so hard to solve, that whenever you hit upon a suspect, you should not really get your hopes up that this must be the guy. This must be the murderer. Because if history is anything to go off, chances are this isn't the culprit. So that kind of claim is being made about the theoretical entities in current scientific theories. It's saying, look, what's happened to most theoretical entities is that they didn't survive theory change. So why do you think the ones we talk about now would survive theory change?
It almost seems like if you were to engage, an argument in response to that question, it just seems like it'd just reek of hubris. Like, you realize everyone else who thought the entities that they'd proposed, they thought they were right too. And all of them are wrong. So what makes you so certain? What new knowledge have you come upon that allows you to be, to prove that you're right, that none of them knew of before?
Yep.
Yeah. You're right, it is pessimistic.
It is pessimistic because it seems pessimistic.
Fair. It seems fair, but it's pessimistic.
Fair. Yes, both of these arguments are the cause of much pulling out of hair, trying to pick a side.
Yeah. I mean, is it worth picking a side?
I
mean, you're suggesting that it can have an impact on, how people approach the process, but.
Well, what I'm going to do is kind of violate my own advice and be a little bit like the taco girl. So sometimes they do in philosophy take what's called a bifurcated view, where they try to take the best of two views and inherit the strengths of each view and try to jettison as much as possible the problems of both of the views. And that's what was attempted here. Some philosophers subscribed to the no miracles argument and were scientific realists. Some found the pessimistic meta-induction too compelling and were anti-realists. And some thought that there were just parts of these arguments that were difficult to deny, and that you just needed a position that could account for why both were convincing. And that's an option.
They both say, like, your explanation of them, I find both of them persuasive. And that doesn't really, I mean, in a pure logical sense, that it doesn't make sense. But
yeah, because they're both pulling in opposite directions.
Right, but they both seem credible. I wonder whether, the answer is sort of outside the problem in the same way that people go, well, who's right, the left or the right politically? And it's like, no, you're asking the wrong question. You need both, because and you need that competition between the left and the right in order to, the important thing is to have that, I guess, respectable tension between both sides, because one is innately capable of seeing flaws that the other one will be ignorant of. And as long as you've got them interacting with each other, even though one isn't perfectly right and the other one isn't perfectly wrong, continual engagement in that process is, might actually be the optimal outcome.
Yep. So I think that's a good reaction. The question is, what would it look like? So I think both is a natural reaction. It's a good reaction. The question is, how do we get both? That's where it really gets interesting.
We got cut off due to a blackout, and we left at pessimistic meta-induction. That's what I think you're about to explain the premise of that.
Yep. So that's the argument against scientific realism, in favor of scientific anti-realism. And I'm going to give a standardization of it, essentially to lay out the argument properly rather than just briefly describe it. So one version of it goes like this. Premise one, there have been many empirically successful theories in the history of science that have subsequently been rejected and whose theoretical terms do not refer according to our best current theories. So where it says do not refer, what philosophers mean when they say that a term does not refer, they have in mind a term like Zeus. So consider the word Zeus and the object in the world that it refers to. Most philosophers would say of a word like Zeus that it doesn't refer to anything, because there isn't actually a guy on Mount Olympus throwing lightning bolts down at people when he's angry, although that's how my neighborhood seemed the other day when our chat was interrupted. Maybe he knew that I was going to use this analogy, was pissed off, and that's why he ended our meeting. But we would say that term doesn't refer. Whereas a term like I'm annoyed when I was searching my mind for people that everyone will of that I came up with this individual, but a term like Kim Kardashian refers. Because there is an individual in the world that the name picks out, that the name refers to.
Got it.
So theoretical content or theoretical terms in scientific theories like electrons, when we are talking about whether or not they refer, we're talking about whether or not there really is a particle-like entity out there in the world that the word electron picks out, and whether or not it behaves like it behaves in any way that, similar to that described by the theories that talk about electrons. Now, if there isn't anything like an electron out there in the world, then the term electron is just like the term Zeus. It doesn't refer to anything. Okay, so premise one was there have been many empirically successful theories in the history of science that have subsequently been rejected and whose theoretical terms do not refer according to our best current theory. So that's premise one. And some examples of those theoretical terms that don't refer are like the ether that I think we've talked about before.
Yes.
They used to think that light propagated like a wave through a medium called the ether. We no longer believe in the ether anymore. So ether would be an example of a term that doesn't refer. Okay. So premise 2 is that our best current theories are no different in kind from those discarded theories, and so we have no reason to think that they will not ultimately be replaced as well. So pretty much that premise is just arguing that all of the all of the characteristics that you'd expect good scientific theories to have, there have been scientific theories that have had all those characteristics and been rejected, just like the scientific theories we have now, which have all these good characteristics that we want scientific theories to have. So, it would be perhaps naive to think that they won't be rejected too. And premise 3 says, by induction, we have positive reason to expect that our best current theories will be replaced by new theories, according to which some of the central theoretical terms of our best current theories do not refer. And that therefore, is the conclusion, we should not believe in now I'm not going to say truth, I'm going to say approximate truth of the successful reference of the theoretical terms of our best current theories. So that's a more formalized or standardized version of the pessimistic meta-induction argument. Now, I said approximate truth there, and before we got cut off yesterday, when we were going for a break, you said it's 12:10, and I said I've got 12:09 on my end, and you said, oh yeah, I'm approximating. That's what I've got on my end too, right? Now, this notion of approximate truth, I should clarify now, because when I describe scientific realism, okay, I was doing it. I was trying to describe both these views first in a simple way but not necessarily comprehensive way before I sort of dialed in and made some clarifications and got a little bit more technical. Now, I describe scientific realism as the view that basically what our best scientific theories say about the unobservable furniture of the universe is true. So if our best scientific theories say there's dark matter out there, then there really is dark matter out there, and the dark matter is the way we describe it, or the way that our scientific theories describe it. Dark matter is a very bad example because it's very mysterious.
Yeah. But that would be like the realist side of it, right?
Yeah. So whatever we uncover from our scientific theories about dark matter, then scientific realists would think that that's the way dark matter is. That's almost what scientific realism is. Okay, what scientific realism really is the claim that it's approximately true. What our scientific theories say about the unobservable furniture of the universe is approximately true. And approximate truth is this notion that has escaped sort of, it's this notorious concept in the sense that it's escaped any sort of precise or formal definition, yet it's indispensable. I think every philosopher agrees that it's a concept that makes sense. It's a concept we can't do without, but it's very hard to precisely pin down and define. Suppose you ask your friend what the time is, and he says it's 6 p.m. when actually the time is like 5:59. Now, ordinarily, we wouldn't think that our friend was wrong when he says it's 6 p.m., but it's actually 5:59. We wouldn't think that our friend was being deceitful or anything like that. Saying it's 6 p.m. when it's 5:59 is good enough. But strictly speaking, the claim that it's 6 p.m. is false. if it's 5:59, then it's not 6 p.m.
Yeah,
Otherwise,
it's
we'd have
literally false, but it's not the difference between what's literally true and what's literally false is so small that it's effectively inconsequential.
yeah, we wouldn't care. But if it was 5:59 p.m. and our friend said it was 2 p.m., we wouldn't be happy with that.
Yeah.
We'd think that we'd be comfortable saying, "Nah, you're incorrect." Right? Whereas if I was to say, "No, it's actually 5:59, you're wrong," I'd be like one of those annoying idiots that go like, "Well, technically all the time about stuff that doesn't matter," right?
Yeah.
So
it's like the you heard people. What was it? A friend sent me a video of this guy. I think he's a fight coach. Was on Joe Rogan's podcast,
Yep.
and he was like, you think that water boils at 100 degrees, but if it starts in this different state, then it actually boils at a different temperature. And you're like, yeah, but you're talking about effectively an exception that proves the rule. Like, unless you put yourself in a what would you call it? An unlikely environment, an unusual environment, it's going to remain true that water boils at 100 degrees.
Yeah, it's just sea level.
Yeah.
And typically we're not, so far above or below sea level, and if you are, the degrees is negligible.
The same thing with weight, right? Like what something weighs at sea level is not going to be what something weighs, 30 kilometers up into the atmosphere. But, people aren't going to care.
Yeah, exactly. So this is the kind of notion of approximate truth that scientific realists mean. What scientific realists actually claim is not that what scientific theories say about the unobservable nature of the universe is literally true. They claim that it's approximately true, in the sense that however whatever gravity happens to be, it's something more or less like what our best physics says it is. Right? And the reason why scientific realists go for this notion of approximate truth rather than actual truth or strict truth is because of the pessimistic meta-induction. Because there's just so many theoretical terms that we found out don't refer. There's a large graveyard of theoretical terms that have been, relieved of their duty. So it's actually approximate truth that's claimed on the part of the scientific realist. So back to the pessimistic meta-induction argument. In support of that, some philosophers have provided this long list. So a philosopher named Lorden is one. They provided a long list of scientific theories that were once in good standing, once widely accepted theories that were now rejected. And all of these theories, or almost all of them, had theoretical terms in them that we no longer believe in. And realists kind of responded to that in two broad ways. There's a lot of responses to it, but you can kind of group them into two categories. So the first is to argue that the list shouldn't just include all scientific theories that there ever were, okay? Because if you want to go back far enough, you've got things that are so just so anti-scientific that were once treated as scientific theories. So, for instance, nowadays, if we pull someone out of the water that's sort of not breathing, we would do CPR, and we know some physiological stuff about the human body, about why that would maybe get them breathing again, or get the water out of the lungs or whatever. But there was a time when they thought that if you pulled someone out of the water that wasn't breathing, I forget what the theory that they believed, which motivated them to do this, was called. But, if you pulled someone out of the water that wasn't breathing, there could be water in their lungs. And so what you had to do was to get this pipe and put it in their rectum and blow smoke up it.
Jesus.
So you had I don't know what you would have called, paramedics back then doing that, and they thought that it would create sort of this air pressure in the human body and force the water in the lungs to come up through the mouth. And you see, you couldn't put the pipe down the mouth. Along with a whole bunch
of shit.
Yeah, you couldn't put the pipe down the throat and blow the smoke into it, because that'd force the water down into the lungs, and all that kind of stuff. So, that we would not call those kind of scientific theories mature. Okay, they exist in a time before the modern scientific age. So with this, we get this notion of mature theories. And just like the notion of approximate truth, it's notoriously difficult to define as well. Different philosophers have their own criteria for what counts as a mature theory. It does seem to make sense, this concept of mature theories and immature theories, but giving a precise account of it, where you could just have like these demarcation principles, so you could like put every theory into either the immature category or the mature category in the history of science, that's difficult to pin down. So exactly what counts as a mature theory is controversial, all right? But the upshot is that the induction in the pessimistic meta-induction argument should range over like less theories than in Laudan's list, for instance, the guy who provided the list of all these theories that have been rejected. Okay. Now, if you could make that list smaller, if you could make the list of theories that should count in the argument smaller, then the realist could claim that there's been less theory change than it appears.
Yeah, okay, it's sort of, yeah. It would be a deceitful thing to do, or at least it seems deceitful.
Well, you're in good company, because there are philosophers that view that move as suspicious. And one of my favorite things to do when I'm trying to make an argument in an essay, if I'm attacking a position or something like that, is to just sort of give the other side as much as I could, grant as much to the other side as I could, and sort of say, suppose all that was true, it wouldn't get you to the conclusion that you want. You can't always do that. You know what I mean? Because sometimes if you give them all that, it would get them to the conclusion they want.
Yeah, so you're talking about effectively steel manning the argument.
Yes. Yep. Yeah. Now, I think if you steel man that argument, even though if you let the list become as small as one wants, there are going to be some theories that are on that list which count in the pessimistic meta-induction argument. In other words, theories that have been rejected with central theoretical terms that don't refer, that would count as mature science under any reasonable definition. So, for instance, Newton's physics is going to be on the list. I don't think anyone, like any criteria that to define mature theory, could rule out Newton's physics.
Are you talking about you wouldn't be able to say it isn't mature, or you wouldn't be able to say that it is mature?
You wouldn't be able to say that it isn't mature.
Okay.
Because most physicists think that, for instance, most physicists regard him as the best physicist in history. So, you couldn't make the list so small that Newton's physics wouldn't be on it. His has got to count as a mature theory, and there are other theories like that have got to count that have got to count as mature theories, whatever reasonable definition of mature theory one wants to come up with. So, for instance, when they did believe in the ether, there was something that was called Fresnel's law, and it described the refraction of light. Now, Fresnel, when coming up with the theory, believed in the ether, believed that light propagated like a wave through the ether. It turns out when we rejected the ether theory, Fresnel's law survives, still gives you the right mathematical predictions, and then we get electromagnetism, and we start to talk about the electromagnetic field rather than an ether, and then we eventually replace the this electromagnetism theory with quantum field theory, and in all of these cases, you have Fresnel's law, which tells us about the refraction of light, surviving. You have Maxwell's equations, which tell us about the electromagnetic field, surviving, and being carried over into quantum field theory, even though the theoretical content that they believed in when they came up with those theories no longer exists. So basically, Snell's law, Maxwell's equations, Newton's physics, they're going to count as mature theories. So even though we might make the list small, I think there's going to be enough on the list to say, look, there's a lot of theories that have been rejected and that had theoretical terms that we don't think refer anymore. In other words, even if we make the list smaller, it seems like a pessimistic meta-induction argument can still get off the ground.
Yeah, so even if you were to make it smaller, it's still not going to be, it's smaller in a relative sense to what it was before. It's not insignificantly small. And there's going to be some names that you recognize on that list.
Yeah. So that was one broad way that realists responded. The other broad way that realists responded was perhaps worse than that. Yeah. So there was a theory. Around about World War I, some philosophers were starting to think that a lot of the problems in philosophy came down to linguistic confusion, and that if we could clarify and make our language more precise in philosophy, we could solve a lot of these problems, and realized that many of them weren't problems and just came down to linguistic unclarity. And this view didn't really take off for a long time, but when it did take off, it really took off. And it was really big in the 70s, 50s to 70s. It was really big. And you had all of these theories come out in philosophy of language that tried to account for how words get their meaning and how they successfully refer to objects and all that kind of stuff. I don't want to go into it too much because it's a philosophy of language talk, but if I did, and this is a philosophy of science one, but philosophy of language, these ideas in philosophy of language came to bear on philosophy of science. And that's what this second response is about. There was this view called the causal theory of reference, and a philosopher named Hilary Putnam, thought that it could kind of solve this, or it was a response to the pessimistic meta-induction argument. So the idea is to argue that the theoretical terms that appear in these rejected or overturned theories actually did refer, just not to what the scientists at the time thought it referred to. So this picture is like analogous to like a murder investigation that undergoes suspect change rather than theory change. And although the term murderer refers to a fixed individual. So, for instance,
is that like the suspect, the primary suspect might change over time, but it doesn't change the fact that what you're looking for is the murderer?
Yeah, but also let's say I'm the murderer. Then the term murderer refers to William Bindley.
Mm-hmm.
Just people don't know it yet.
Yeah. Okay.
That's the idea.
Yeah. So I guess when you talk about like the ether theory of light, that's pretty much the same thing, right?
Yeah. So if it turns out that there's no such thing as an ether, and rather than there being the ether, there's an electromagnetic field, then the term ether really refers to the electromagnetic field, even though no one at the time, before Maxwell, had any inkling of what the electromagnetic field was.
Yeah, right.
Right.
Do people worry that seems like a get out of jail free card?
Yes.
Yeah.
Yes. So one of the criticisms of that response was that it kind of trivializes reference. It makes it just, you can say whatever you want. You can make up you can postulate some entity that you think is out there, and you can be just drastically wrong, but you're going to successfully refer to what actually is out.
Yeah,
you can be nothing but wrong and get it right. That's kind of how it feels.
Yeah, it seems like it would be incredibly. I mean, I guess if you approach that process and that potential shift of meaning sincerely and maturely, it might be all right. But it seems like someone would come along quite comfortably and say, "Oh yeah, but this is a slippery slope." You sort of, you have those frustrating arguments with someone who doesn't really know what they're talking about, and they say something that doesn't mean what they think it does. And you go, look, this is what that word actually means. You go, yeah, that's what I meant. I forgot. That's sort of, it's sort of like allows you to remain correct. I'm trying to, it sounds like it would be immensely frustrating.
Yeah, it was. I remember talking to a guy years ago that was trying to tell me that he used to work for the NSA. He's an American guy. And he said, I used to work for the NAS. And I was like, oh, you mean NSA? And he was like, yeah, that's what I meant.
Yeah, I do that. I try and get out of it by like looking confused and like, wait, what did I say? Yeah. Like, you said this, I'm like, oh, okay. But, deep down inside, I'm like, I know I just misspoke.
Yeah, we've all done it. Now, as you've pointed out, there are issues with this. The first one, you pretty much hit on the head. It kind of trivializes successfully referring to things, and it feels like a get out of jail free card. So I'll move on to sort of a second one, and I don't know if this, like, I came up with this idea, or not. I like what I mean is I haven't read it somewhere, but the amount of times where I think I've come up with something original, only to find someone else thought this way before me, and that I can't sort of pursue it, you know what I mean, and expect to be the first to get anywhere with it. Like, I've lost count.
There's a quote from I think it was Harry Truman, who said, "The only new ideas are the history you don't know."
Yeah, that's how life feels every day when you think you got a good idea.
Yeah.
Yeah. So
you see it in music a lot, where someone will say, oh, this is this new genre, and you're like, no, that's actually a really old genre, and it's so old that you don't know it existed, so you just gave it another name, but you're actually referring to the same thing, even though you're unaware of it.
Yeah. Actually, so what I was getting at, for your listeners, is I don't claim to have come up with this. You know what I mean? Like, no one told it to me, but I'm sure other people have thought of this way before me.
Oh, okay. I see what you're getting at. Yep.
Yeah. Actually, first I'll go with one that isn't that one that I'll give a quicker one first, which comes from other philosophers, and then I'll give the one that it sort of came up with independently. But if you take, for instance, Newton, when he was talking about gravity in his theories, and we know that Einstein's gravity is so different from Newton's gravity, it does seem pretty implausible that when Newton talks of gravity and has in his mind the idea of this sort of attractive force exerted on one mass by another through this action at a distance, what he was really referring to was gravity as described by Einstein, if that's what gravity turns out to be, which is, like the locally active curvature in space-time due to the presence of matter. It does feel implausible that that's what Newton was actually referring to when he says gravity, even though he had not the slightest idea of that. And if you were to ever suggest to Newton that that's what gravity was, he would think it was preposterous.
Yeah, and they both provide sufficient detail to explain what they mean by gravity, that you don't have to go through the simplistic approach of saying, well, you're both using the word gravity. You're like, no. They're using gravity as like an umbrella for a much more complex explanation. And if we compare those complex explanations, we can realize that, despite the same word, they actually have a different meaning. Yeah.
We'd be totally justified in having different words for them, for Newton's gravity and Einstein's gravity. And so if we were to take this causal theory of reference answer seriously, it would mean you couldn't take not taking scientists at their word. So when a scientist says, I think that that a particle is like such and such, it means not taking them at their word, because particle, they could actually be referring to some other kind of description of particle, which more modern science than the science we have now will uncover or describe, without the scientist that's telling you what he thinks particles are, even knowing that. Mm-hmm. Even knowing about it. So it means scientists referring to things that they've never heard about, even though that's not what they mean to do. When a scientist says to you that this is what I think a particle is, I think we should take the scientist at their word.
Yeah. Well, I mean, if you don't, how can you do anything productive after they tell you that thing?
Yeah. When Newton tells you he thinks gravity is like this, I think you should take Newton at his word, and think that Newton is referring to the way the gravity that he describes, whether or not gravity turns out to be something entirely different. So, yeah, it does seem implausible that, Newton's really referring to something entirely unbeknownst to him. All right. Now, this is the part where I came up with this by myself, but I'm sure people did way before me. This is the strategy of granting everything to sort of this causal theory of reference response. And let's see what that would look like. So if the causal theory of reference, if we accept it, and let's regard it for what it is, it's an attempt to save reference, because the issue for the realists is that these theories are getting rejected, and with that, the theoretical entities in those theories don't refer. So we want to be able to say, if we're scientific realists, that they do refer, just not to what we thought.
Yeah, so he's sort of like massaging the definition in order to solve the referral problem.
Yeah, that's the strategy. Okay. And suppose we're cool with that. What would that do to realism? What would that do to scientific realism? Okay. The reason that scientific realism is attractive is because that if scientific realism is correct, then we can be confident about what the unobservable furniture of the universe is like. That's why it's attractive.
But if you're letting the potential meaning shift to describe, fundamentally different entities over time, doesn't that compromise that the aspect of it that you're talking about, though? Like it
does.
If you're saying, the universe is full of chairs, and you go, okay, what do you mean by a chair? You give a description of it, and it turns out that it's actually something slightly different, like say maybe it's a stool or something like that. And you go, well, yeah, but a stool is still a chair, so we're going to keep that. Like, yeah, but the entity that you thought existed and that you were describing is not the entity you meant initially.
Yeah.
So it's, you sort of eating your cake and having it too.
Yeah. So what this causal theory of reference, this response does, is to basically defend scientific realism at the cost of the appeal of scientific realism, the cost of what's attractive to scientific realism. And, if scientific realism was right, then we could be confident that all of the stuff out there that we can't observe is probably something similar to what our best science says, and that the theoretical entities that those scientific theories talk about actually explain why we observe what we can observe. But that's not the realism on offer under the causal theory of reference response, because those terms might actually refer to something entirely different.
Yeah, it seems like, yeah, it just seems like a huge dissonance between the two. Like it just seems like a willful delusion in order to salvage the idea.
Yes. Yeah. So in philosophy, that's called like an ad hoc move. This willful disillusion to salvage this idea. So like if we just think about that, the kind of scientific realism that would be left over if we thought that the reference worked the way that the causal theory of reference supposes, then we wouldn't be successfully postulating the right theoretical entities in our best scientific theories, and we wouldn't be successfully describing them. We'd just be successfully naming them without the faintest idea of what these names refer to, and we just know that they do refer.
Doesn't that end up equating to something much closer to like an anti-realist position then? That's what
my point is.
Yeah,
that's exactly what my point is that if it's like about the platform shift between the Democratic and Republican Party way back in the day.
Oh yeah, like yep.
Yeah, so I mean the Republican Party used to be the left party, and the Democrat Party in the US used to be the right party, and in order to try and snag some of each other's voters, each moved closer to the center until it became easier to just
like
swap places.
Split.
Yeah,
Does this what you're talking about? That seems like I'm struggling to clarify the link, but it seems like it's falling into the issue that the causal theory of reference was trying to solve. The phenomenon that it's explaining, that if what you're putting forward is an accurate representation of how people tried to say realism, they're actually just using another word to describe something that already exists, except instead of recognizing that, we're using two different words that describe the same thing, they're using two different words and pretending that they describe different things. Whereas, it seems like one on the realist side might actually just end up being, a slightly varied description of the anti-realist side.
Yeah. So if you run with this, it seems like scientific realism is just going to look so much like anti-realism. And, you know, so when I said, you know, that the scientific realists responded in two main ways, and that was the first one where you wanted to shrink the list that's used in the pessimistic meta-induction argument, and the second response is the causal theory of reference. If you're a scientific realist, and there are other responses, but these were the two main ones, you couldn't side with both of those strategies, because the strategy of shrinking the list would defend a scientific realism that looks very different to the kind of scientific realism you'd get if you went with the causal theory of reference response. Yeah. So this kind of caused a bit of a schism between scientific realists.
Yeah, I imagine it would.
Mm-hmm.
I mean, it's like causing a schism in my brain. I'm trying to think,
Yeah,
like,
same.
how do they? How do they continue to defend the position then? Do they continue to defend the position?
There are not. There doesn't seem to be as many scientific realists as there used to be, but what this did was it motivated a third view, one that tried to find a middle ground between scientific realism and anti-realism. So I'll get to that, because that's kind of what this all led to.
Mm-hmm.
But I'll get to that to the end, because if I kind of bring it up now, it'll be a bit of a rabbit out of the hat sort of thing. So yeah, there were two. Those were two sort of main responses. Now, in order to be fair to both positions, I've just sort of explained the pessimistic meta-induction arguments and how the realists responded to it, and sort of I didn't make the realist response look very good. So I'd agree with that. In order to not sort of be biased, I'll talk about the sort of some of the issues with anti-realism as well. So if we recall the no miracles argument, now the no miracles argument, in summary, says that if our best scientific theories aren't approximately true, then it's very difficult to explain the success of science.
Yeah.
Science is remarkably successful. So much technological innovation and human flourishing comes about from, as a consequence of our best scientific theories. So if there wasn't something that these scientific theories were getting right, this would just be this extraordinary run of luck. And this is like a challenge to the anti-realist, right? And it's basically to say that if the approximate truth about theoretical entities doesn't account for the success, this remarkable success, then what does? So that's a difficult position to be in, I think, for the anti-realist too, because sort of what can you point to other than what the scientific theories say about theoretical entities that explain the success of science? You can't point to empirical entities, stuff that we can, that we can observe and we've been looking at for years, because humankind's been looking at that since it's existed, and has only up until recent times enjoyed such such a high degree of scientific progress. So it's like that's not an enviable position to be in either. And yeah, I've spent ages trying to think about which side I would fall on, because of both of these arguments. They both seem convincing, and they pull in opposite directions.
But I mean, you can be, approximate, depending on what it is that you're trying to do. But sometimes an approximation, like in the case of Newton, is enough to sort of get you close enough to it, that you don't need a miracle to explain how you got there. You might not be 100% correct, but you're so close that, you can comfortably say it's not a miracle, even if some of your assumptions turn out to be, slightly wrong. In some sense, it sort of puts you between the two positions, I guess, like at least between the two extremes of the positions.
Well, that's a good point, because in you're talking about sort of approximations not being absolutely correct, but still being successful. Well, if you think about the no miracles argument, there is an assumption in it, and it's kind of unstated. And typically, when you have an argument that has sort of an unstated assumption or a suppressed premise, so to speak, you want to tease it out and make it explicit. And the assumption is that false theories wouldn't succeed, and true theories would succeed. Now, just like you're saying with Newton, the theoretical content of Newtonian mechanics is false, but it's successful. It's successful enough to get us to the moon. It successfully predicted Neptune. I think we were talking about that in the last video. So the idea that false theories would be unsuccessful is false. False theories can be successful. Whereby successful, I mean yield accurate predictions. They can yield successful predictions. So we know that claim is false, that false theories will be unsuccessful. But what about the assumption that true theories will be successful? Just in case I said that wrong, I'm going to rephrase it and mix this. Okay, so the first claim is that false theories will be unsuccessful. And I've just sort of explained why that's not the case. You can have false theories that are successful. All right. And the other claim is that true theories will be successful. Now, that claim is more complicated, more interesting. Okay. Now, and presumably a theory that just gives you a complete and true description of the unobservable world, like you just imagine, like just cracking everything, presumably that would be a successful theory. If you got everything right about the unobservable furniture of the universe, that theory would yield successful predictions. All right. But, no one thinks that we have anything close to that. And most people think we would never have that. So even scientific realists will say that we probably don't have any true theories. Instead, what the realists would claim is that we have at best approximately true theories. And
that seems. When you look at the way science is done now, it's not saying, you're trying to disprove a hypothesis, not prove it. So you could never say, while you might be able to say that something is clearly false, you couldn't say that something is true or this theory is correct. All you can say is, it seems to be incredibly close to whatever, reality is. And we know, we can't know how close it is unless we were, able to say, yes, this is perfectly true. But you're close enough that you can do stuff, with your answer.
Mm-hmm. Yep. And the issue that comes up is that if you've got approximately true theories, can yield sort of infinitely many true predictions and infinitely many false predictions.
Mm-hmm.
So just to clarify for your listeners, what I'm saying is that if we had a true theory, a strictly true theory, well, presumably this would yield nothing but success in terms of predictions. And what I'm saying is that if you only have approximately true theories, which is all the scientific realists claim that we have, approximately true theories, then you from approximately true theories, it's a wild card. Anything can happen. And I'll give you sort of an example to clarify what I mean by this. Let's suppose I make like a list of all the home and like the contents of my home, right? So I've got this list of all my home contents, but I'm missing one thing. There's one item in my house that I've left out. Now, this list, we'd say it's approximately true. It's only missing one item. All right. So you actually can't make it closer to being, you can't make it more approximately true.
Yeah.
Because if you improve the list at all, it just would be true. It would have all the items.
Yeah. But how much you care about, how close I guess how much you care about that approximation might depend on what's the item you left off the list.
Yeah.
Like, what if it was, I don't know, your wallet or your keys? If it's, oh shit, I left a hairbrush off the list.
Yeah.
Yeah, who cares? Be like, oh shit, I forgot my kids. Then you start to panic.
Yeah. So this list is actually going to get a lot of stuff right. It's going to get a lot of predictions right. If you wanted to predict what books you could read off my shelf, that list is going to be pretty good. If you wanted to predict whether or not you could host sort of 4 people at a dinner party, it would tell you whether I've got enough cutlery and whether I've got the space or the furniture and all that kind of stuff in my place. There's so many predictions that you could imagine that this list would get really well. And there's also so many predictions that this list could get incredibly wrong depending on what the item is. So for instance, if the item that I left out was like the Mona Lisa painting, mm-hmm. and suppose I own it legitimately, I didn't steal it or anything like that, then the prediction for the value of my home and contents insurance, this list gets it drastically wrong.
Yeah.
In fact, a more accurate list would be if I put the Mona Lisa painting on the list and deleted every other item on the list, and then an insurance company calculated the home and contents value for my home, that would be more accurate.
Yeah.
And this list is actually not approximately true.
Yeah.
It's not even close to approximately true because it gets the smallest number of things correct that it could get correct. One thing.
Yeah. But that thing's so important.
Yeah.
Okay.
Yep. So to make this not sound like a sort of a silly analogy about home and contents insurance, I'll sort of tie this back to, for instance, like a scientific example. If we think about the initial conditions required for the Big Bang to occur and sort of bring the universe into existence, okay, these conditions, physicists tell us, are very specific, and to the point where, if there's just a tiny bit of difference in these conditions, it might not have happened. So let's imagine 2 lists of conditions. List 1 and list 2. List 1 gets the conditions strictly true. Suppose that was possible. We knew properly what the conditions were. Now, list 2, let's say, just sort of leaves one condition out. Well, the second list is an approximately true list.
Mm-hmm.
It only leaves one condition out. That's as close as you can get to being approximately true. But it matters what the condition is that you leave out, because it could mean the difference between universe existing and no universe existing. List 1 predicts that a universe is going to come into existence after a great big explosion. List 2 might not have the ingredients for that to occur. The condition left out could be so essential such that it doesn't allow that explosion to occur, and you don't get a universe coming into existence. And the difference between universe existing and no universe existing is a chasm. So it matters what we're approximately true about, what gets left out. And
how can you know how approximately true you are, like how close you are to that high level approximation?
That's the biggest issue. You can't.
Yeah.
In principle you could, and that would be by knowing what is true. But if you knew what was true, then you wouldn't need approximately true theories. You could make a true theory.
Yeah.
And science would be done. So, in reality, you can't. Sort of in principle, we could imagine it being possible, but in reality, you couldn't. And that's what the issue is. So approximate truth sort of doesn't guarantee predictive success. So you can have you can have predictive success with or without approximate truth, and it sort of doesn't guarantee it. And there might be other things that could explain predictive success in science. It might not be the approximate truth of theories, whether or not they are approximately true. So this is a difficult issue. Now, I mentioned, I think, before we got cut off by the storm, novel predictive success.
Yes.
Yeah. So novel predictive success, and just let's say just the alternative or the opposite is just carried over predictive success, which I'll just refer to as carryover content. That's basically when for instance, Newton's physics predicting the existence of Neptune successfully. If you're going to replace Newton's physics with Einstein's physics, then you need to be able to look at Einstein's physics and say, suppose we didn't know about Neptune. Okay, could we look at Einstein's physics and predict its existence from it? And the answer has to be yes. Otherwise, Einstein's physics is not a candidate to replace Newton's physics. So everything that's successful about the previous theory has to get carried over. So that kind of success is not remarkable because it's inbuilt into a replacement theory. So it's not just all success in science that's remarkable. It's novel predictive success. It's the novel predictive success that we need to explain and make not look like a miracle. We need some explanation for novel predictive success. The prediction of the existence of Neptune is novel predictive success with respect to Newton's physics, but not with respect to Einstein's physics. Right?
This ties back to something you were talking about earlier, and I can't remember what it was. Might have been we were talking about, how do you compare two theories that try to describe the same thing?
Maybe we're talking about Kuhn?
Ether. No, I'm thinking more like we're talking about the ether theory of light. You're like, well, it was wrong. You're like, well, the novel predictive success of electromagnetism is why this is superior to, ether. So does that allow you to compare competing theories, or whether one should supplant the other?
Yeah. So let's say if there was another competitor to replace Newton's physics, and let's say the only difference between Einstein's and this other competitor is that Einstein's theory makes more novel predictions. Maybe we've sort of verified them already, or we haven't. You would take the one that enables more novel predictions because it's more testable. Yeah. So a real life example of that was the gravitational waves, for instance. So Einstein's theories years ago, before we had the technology to detect gravitational waves. In fact, I think it's only it's less than 5 years ago that we actually detected them. He detected gravitational waves, technology caught up, and he predicted gravitational waves, and technology caught up, and we actually detected them. That's novel predictive success. Whatever theory replaces Einstein's in years to come has to carry over that success into its theory. And with respect to that future theory, the prediction of gravitational waves is not novel.
Yeah.
Yep. But it is novel with respect to Einstein's.
Okay.
So even though not all success in science is sort of remarkable and requires explanation, novel predictive success does require explanation. So the challenge to the anti-realist posed by the no miracles argument is really the challenge to explain novel predictive success, not just any old predictive success, because a lot of it's carried over. And it's basically saying that if approximate truth doesn't explain novel predictive success, then what does? And there's a famous answer from a philosopher named Van Fraassen, and he's an anti-realist. And his explanation, or his attempt to explain it, is like this. So he thinks of sort of science and the way that the scientific method works as a survival of the fittest. So science, the conduct of science is like analogous to Darwinian natural selection. Only the fittest theories are going to survive. All things considered equal, successful theories are going to be selected, and unsuccessful theories are going to be rejected. So that's precisely what you should expect. If you built a system that functions like a selector, and it selects for a criterion, and the criterion is predictive success, then the only things that are going to come out of that process are going to be the ones that have predictive success. So this response doesn't just make it, unlike the no miracles argument, where all of the novel predictive success seems like a miracle, if you don't believe that the theories must be approximately true. This one kind of flips that on its head by saying that happening is precisely what we should expect to happen. If a selection process is only going to choose theories that exhibit novel predictive success, then the real mystery would be if science was not remarkably successful.
Okay.
A way to explain this is consider, I know you know this, but not everyone does. In the Australian Army, for instance, the Premier Special Forces Regiment is the Special Air Service, or the SAS. They have this grueling selection course. So, and then they have this very grueling training regimen. So that, this process is designed so that the only guys that come out the other end are guys that are extremely good soldiers. So if you had this process in place that just isn't going to let anyone but top-notch soldiers come out the other end, the mystery would be if you weren't getting top-notch soldiers coming out the other end. You wouldn't think that it's a miracle that you're getting anything other than extremely good soldiers coming out the other end. So if you've got this process and this method of doing science that just isn't going to let anything that doesn't have the goods get through, it shouldn't be a miracle that when you look at the other side of the process and see everything that does get through, it's stuff that has the goods. It's stuff that's successful.
Yeah.
So when you put it that way, the success of science doesn't doesn't look so mysterious without appealing to approximate truth. Now, before we get too attached to this response, there's problems with it. It's just, they never end. Like, the problems never stop. There are two ways to interpret the question of, if approximate truth doesn't explain the success of science, then what does? Okay, and the difference is like this. Some people describe it as the difference between sort of a global question and a local question. So Van Fraassen, the philosopher who proposed the sort of survival of the fittest with the theories, explaining why science is so successful, that is an answer to the question of why there are successful theories, right? That's one question. But a question like, why is this specific theory successful, like theory T, for instance, it doesn't answer that question. So, for instance, if we go back to our analogy with the special forces selection, the question, why are special forces soldiers such good soldiers? The selection process answers that.
Mm-hmm.
Because no one that isn't good, no one that doesn't have the potential is going to ever be a special forces soldier.
Yeah, the whole point
Right.
of the process is to weed out, suboptimal candidates, suboptimal candidates, whether it's science or special forces.
Yep, exactly. Right. But if you were to look at an individual, let's say, like, let's just call him Soldier X, right?
Yeah.
You look at this individual, you say, but why is Soldier X successful? You can't appeal to the selection process to explain why Soldier X is successful.
Yeah, okay. So you're talking about the success of that's what you mean by like global and local. Like, so
Yes.
the success of the selection process as far as, getting the right individuals, well, that's the whole point of the selection process. But then as far as, well, even with the success of the individual, wouldn't you have to investigate why the individual is successful in relative to the selection process itself?
Yeah, and also relative to the individual. You'd have to tell a story about the sort of the personality traits that the individual has.
Oh, yeah, okay, I get what you're talking about. So, yeah, like how does that person get to be a successful candidate?
Yeah.
Yeah.
Why does he have the goods? Why does sort of candidate 73 have the goods and not candidate 19?
Yeah.
Right. And you can't say that it's because he passed selection or something like that. It's because that puts the cart before the horse. The fact that he had the goods is why he passed selection.
Yeah.
Okay, the fact that he passed selection isn't why he has the goods. That's just how we figured out he had the goods.
Yeah, okay.
Yeah. Now, that's the local question. And it doesn't seem like Van Fraassen's answer is a response to sort of the local question. It's just a response to the global question. So, why is science successful? Sure, the selection process answer seems pretty convincing. Why is quantum physics successful? Doesn't answer that.
No, I would have thought like it'd go back
theory.
to novel predictive success.
Yeah, novel predictive success, but why? Why is it that quantum mechanics predicted novel had novel predictive success, and not some other theory? Right. The selection process just tells us, that just explains how we figured out that quantum physics was the one that gave novel predictive success over whatever competitive theory.
Yeah, I think I get what you're saying. At the same time, It's like I can feel it hurting my head.
Yes.
A little bit.
I like it.
I'm like, oh yeah, the answer's obvious, and then I try to find it. And I'm like, oh wait a second. Like it's feel like I'm about to start going around in circles.
This one's a subtle one, and it's one of those things where like I read one sentence and sort of sat there for 30 minutes or whatever, and then read it again and sat there thinking about it. I remember when like the page that this was on when I was reading, whether it was a book or a journal article, was took me like I spent several hours with it. You know? It's like I just slowed down to this pathetic pages per minute, or pages per however many minutes rate of reading.
Yeah.
But it does kind of lead to something interesting as well, because sort of trying to think about how to explain this. So let's just think about how explanations work, because there's like we're thinking about this Darwinian process that's only going to select theories with the goods. And we're saying that explains why science is so successful. But if you wanted to know why an individual theory was successful, it doesn't explain that. So that's where we're at. And let's sort of think about how explanations in selective processes work, such as in evolution. Let's suppose the idea I'm trying to explain here is independent testability. So let's keep that in mind as I kind of tell this story. Suppose we wanted to explain why dogs are so successful at sort of tracking, either tracking drugs or tracking criminals or whatever when they've caught a scent. What we might do is we might think about the kind of nose you would need to be able to track successfully. And let's say that it's a nose with property X. So if you had a nose with property X, then you could smell the way dogs seem to be able to smell. You could successfully track with a nose like this if you had a nose like this. So that would be like an example of the first step to explain the dog's tracking success.
Which is coming up with a working hypothesis.
Yeah, basically. Then we might explain how a nose like that could have come about in evolution. So, we might come up with an explanation as to how a nose with property X, or even just property X itself, could have evolved in response to adaptive pressures in the environment and stuff like that, right?
Mm-hmm.
And then finally, we'd have to claim that dogs actually have noses with property X.
Yeah.
Right. This is like what the scientific realist does. The scientific realist explains that a property, which is approximate truth, would, a theory with property X, a theory with approximate truth, just like a nose with property X, okay, would explain, would enable a scientific theory to make successful novel predictions. Right. Then you could explain how the property of approximate truth could have come about. You could just talk about all the trial and error that science goes through in order to make the hypotheses better, or the theories better. And you could talk about Popper's method and falsifiability and all that. And then the final thing, just like we claimed that dogs have noses with property X, would claim that theories, science has theories with property X. Science has theories with approximate truth, right?
Mm-hmm.
And that's taken to be an explanation for the novel predictive success of scientific theories. Now, notice in the case of explaining why the dog is a successful tracker, it sounds all right, but it actually doesn't pass the minimum standard of it, like a good scientific explanation as far as sort of Darwinian selection goes, because we've left out a crucial final step. The crucial final step would actually be to go and verify whether dogs have noses anything like property X. Okay?
Which is the testing of the hypothesis.
Yeah. So if I want to explain a polar bear's ability to survive in the cold, I might claim that a furry coat would help him do it. Then I could explain how a furry coat might have evolved under adaptive pressures. But if I don't actually go and check that polar bears have fur coats, right? Maybe polar bears bloody like bald, like Sphinx cats or something.
Yeah.
If that's how polar bears actually were, and here I am talking about fur
like
coats.
Walrus with just massive amounts of fat on it.
Exactly. Then my explanation is it doesn't pass the minimum standard. It's no explanation at all.
Mm-hmm.
I'd have to go and check what dogs' noses are like, and I'd have to go and check whether polar bears have fur coats. So this is actually where the scientific realism comes from. It's not because it's not because the scientific realists want to say, oh, this is realism about science, as opposed to sort of realism in politics or political theory or anything like that. They're not trying to characterize what field of academia they're talking about. They call it scientific realism because some of them think that the explanation of the success of scientific theories, the novel predictive success of scientific theories, by appealing to approximate truth, is a scientific explanation, like the one with the polar bear and the dogs. So they take themselves to be actually giving a scientific explanation for the success of science itself. It's kind of like using science to explain why science works.
Is that cheating?
Maybe. Yeah.
I mean, I'm sitting here thinking like I need to push back and like tease this apart, but like I'm like running at 100%, trying to keep up.
Probably doesn't help how animated I get.
Oh, no, I'm not too worried about that. I've sort of, I guess, yeah. I'm sure when I go back and listen to it, I'll be like, oh yeah, okay. But yeah, at the moment, I'm just trying to keep up. I mean, it seems reasonable, and parts of it seem, familiar. That you go, well, if I notice, like you were just talking about some sort of behavior. And in order to be successful in that behavior, I would expect that animal to have certain traits or capacities. This is how I think those traits or capacities could have come about. Now let's go and actually see how approximate, my idea of truth is by seeing whether they actually are present and check the animal.
Yeah. So that's pretty much it. Doesn't sound like you've left anything out to me. So here's where it sort of gets bad, is that unlike with the case with the dog or the polar bear, where we can go check its nose, because presumably some other kind of nose with different properties could also enable successful tracking. Yes, right? Okay. Unlike with scientific theories, we can't go and check to see whether our theories have approximate truth. For the reason that you brought up earlier, that unless you know what is in fact true, you can't tell how close to the truth some theory is.
Yeah.
There's no test for approximate truth. Like there is a test with the dog's nose. You could say, well, a nose with property X could enable it to do it, but so could noses with property Y and property Z.
Does this mean the best you can hope for is approximate truth, but you also can't know how approximate it is?
That's the case. It's also worse than that. You don't even know whether it is approximate truth that accounts for the success. You don't know unless you check whether it's a nose with property X that enables the dog to be a successful tracker or a nose with property Y or Z, when other kinds of noses would enable successful tracking and may have evolved under adaptive pressures during evolution. So just like we don't know whether the theories have approximate truth, and if they did have approximate truth, we don't know how close to the truth they are. We also don't know if sort of approximate truth would enable the or if we don't know if I'm trying to think about the noses, put this in a way that sort of does just sort of syncs up with the noses analogy. We don't know if it's that property, approximate truth, that accounts for the success. It might be some other property that accounts for success, is what I'm saying. Right? So we don't know that it's a nose with property X or a nose with property Y or Z, unless we go and check the dog, but which in that case we could do.
But you can't do that with approximate truth.
Can't do that with approximate truth. So you don't know whether it's approximately true, and if it is approximately true, how close to the truth it is. And you also don't even know if that's the thing that would get you the predictive success. It could, but we've seen that there are issues with that, with the sort of the Mona Lisa home contents sort of thing. There could be many other things that could explain predictive success that scientific theories might have.
Yeah.
So I feel like we've sort of reached that point, like when we were with Kuhn.
Mm-hmm.
And it was just very much like an attack on the head.
Yeah.
This one is
it's pessimistic.
Mm-hmm.
But it seems, it doesn't seem unfair either.
Yeah.
And I guess it's pessimistic. It doesn't seem unfair, but it seems like it should inspire a degree of, a fairly heavy dose of humility.
Mm-hmm.
And, ideally not being, too wedded to ideas when, it just seems so fickle. But I guess that's not the case, especially if it's your idea.
Mm-hmm.
Yeah.
Science is the best tool for acquiring knowledge, so to speak, of the world around us, and it's not,
and it's still that
as good
flawed.
It's still that flawed, so it's just humans kind of suck. The humans kind of suck at figuring out things. That's the humbling part to me when you're talking about it inspiring humility. We sort of think about sort of how far we've come and how amazing it is. If we think about people in caveman times, sort of you're lucky if the stick that you're trying to spear the animal with has a pointy rock on the end. Compared to now, that kind of picture of progress and human prosperity makes us out to be sort of so amazing. We must be so good at figuring out things about the world we
if
live
anything, it makes the progress that we have had even more incredible.
Mm-hmm.
You just think, like, the odds are so against you. It's not that I can't believe, why haven't we made more progress? It's more like, I can't believe we've made as much progress as we have.
Yeah, that's what I'm getting at. Like, it's so in that sense, it's mysterious. Yeah, the fact that we have made all this progress, and it's been a chaotic, not algorithmic in the slightest activity. That's brought us so far. Now, I should mention the third view.
Yep.
And
this was the compromise sort of position you were talking about.
The compromise, yeah. Because even though I've said more about the issues with realism, that doesn't mean that it's not a numbers game. It's not just a numbers game when it comes to evaluating the strengths and weaknesses of positions. So, if, for instance, one position might have less problems with it, that doesn't mean it's the better position, because severity of problems is an issue too.
Yeah, the same as what you leave off your home and contents insurance. It's not how many things did you leave off, but what was the value of what you left off.
Yes. So, I wouldn't assume that just because I sort of I mentioned all of these issues with the no miracles argument and scientific realism and approximate truth that anti-realism looks better or anything like that. The severity of problems counts too, not just the quantity. And one of the really severe problems with anti-realism is the fact that even though approximate truth about theoretical content doesn't guarantee success, as we've seen, like the home and contents example, there is stuff that's carried over during theory change that seems to survive, even though the theoretical content dies. So, for instance, Fresnel's law describing light survives. Maxwell's equations survives when we replace the theories about electromagnetism with quantum field theory. We have stuff that stays intact and gets retained from theory to theory. And if that stuff is staying intact and getting retained, that suggests that there's something right about the way the world is that these parts of theories that get carried over must have captured.
Yeah.
Right? But notice that when these theories are getting replaced, theoretical entities, theoretical terms getting left behind, like terms like ether and stuff like that, right? So it can't be that kind of stuff that it was getting right. It can't be claims about theoretical entities, unobservable entities, that it was getting right, because those are the things we're ditching in favor of new ones. So the idea is that it's the structure of the universe, some part of the structure of the universe that these theories are getting right, which is surviving. So you have theoretical terms not surviving theory change, but you have claims about the structure of the universe, the structure of some phenomena surviving theory change. And what this gives rise to is a view called structural realism. Mm-hmm. And this is like the compromise between anti-realism and scientific realism. So what structural realism claims is not that what our scientific theories say about the unobservable features of the universe is approximately true. That's the claim of scientific realism. Structural realism says that what our best scientific theories say about the unobservable structure of the universe is approximately true. And then structural realism sort of has its own branches as well. There are different kinds. So there's two issues. Is, like which kind of structural realism is one, and the other issue is what is structure? What are you talking about when you say the word structure? So structural realists differ. Some say it's mathematical. Some say it's actual physical structure. But the thing that they have in common is that it's not the entities that are important. It's not the entities that we're learning about when we propose these scientific theories. It's the relations between entities. So for instance, if I've got, let's say, 10 books and I put them in order of thickness, I order them from 1 to 10, 1 being the thinnest book and 10 being the thickest, there's a structure between those books. And you can understand what the situation I've described there without knowing anything about the books, other than the position they occupy in the ordering that I've specified.
Yeah.
You don't know what color any of the books are. You don't know what the title of any of the books are. So there's a sense in which so much about the entities, in my analogy, the books, doesn't matter at all. But what matters is the relationship between the entities, the relationship between the books. And in my example, that relationship is like thickness.
Mm-hmm.
So I know that's very vague because it raises so many issues of like, well, hang on, don't you need to know something about the books, specifically how thick they are, before you could put this in this sort of order? And yes, that's an issue, but it's a very long road to go down structural realism, and it gets very mathematical. I will point out, well, it can get very mathematical, or it can get very physicsy, and there's a lot that I sort of wouldn't be able to do any justice to without sort of diagrams and stuff. So before I sort of leave the discussion there, I'll just mention two kinds. When structural realists say that what the scientific theories tell us, or the theoretical content of scientific theories, what they tell us, what they reveal to us, is the structure of certain phenomena rather than information about the entities. The question comes up, well, then what do you claim about the entities? Do you claim that the entities don't exist and all that exists is like sort of these relations, such as heavier than, taller than, things like that? Or do you claim that there are theoretical entities out there and we just can't know about them, and all science can investigate is the relations between them, which is to say the structure between these unobservable entities? So in other words, there are structural realists who think that there are no sort of theoretical entities or unobservable entities, and there's just relations, which is very bizarre. And there are structural realism. So that's called ontic structural realism. And then there are structural realists who claim, no, like I'm sort of, agnostic about whether there are these theoretical entities out there. It's just I don't think science can tell us anything about them, and instead what science is going to tell us is the relationship between whatever theoretical entities happen to be out there. Mm-hmm. So yeah, I think that's a good place to leave it.
Yeah.
That's the third view.
So just to recap, so we've got essentially on one side you've got realists, on the other side you've got anti-realists, and then structural realism sort of straddles, I guess, a position between the two that, may lean more one direction or the other.
Yeah. I should actually say this too. The reason structural realists took this route was because they felt like they needed something to answer the no miracles argument. And the no miracles argument, if the theories aren't approximately true about the theoretical content of the universe, then the success of science is a miracle. Structural realist can say, well, what explains the success is that it gets the structure right.
Yeah.
Not that it gets not that it tells us correctly what theoretical entities that are out there. It just tells us what the structure must be like, approximately. And also, structural realists can sort of respond to the pessimistic meta-induction by saying, because the pessimistic meta-induction argument says that because so many theoretical entities have been rejected, why would you think the ones we talk about now are the ones that are actually out there? Well, then the structural realist can respond to the pessimistic meta-induction argument by saying, well, I don't really care what theoretical entities are out there because I've just got this structure that seems to survive theory change. And that's what I hold on to, not the theoretical entities. So I'm not actually wedded to anything that does have a history of being replaced.
Yeah.
And all the time. So that's what the motivation is to go to structural realism. And all of those three still exist in abundance: scientific realists, anti-realists, and structural realists.
Yeah, I think I'm going to have to go back after this. It's probably going to take me a couple of weeks. I think to sort of be like, okay, I think I get this now. But yeah. That was awesome. Difficult, but awesome. I really appreciate you doing it, man. Is there anything else you want to talk about before we wrap up? Go get some lunch.
I'd just like to thank you for having me come on. I had good fun myself. It's always good catching up with you too. And it's pretty much it. I hope your listeners don't sort of have the same problem as us, where we just sort of brain fry ourselves. I imagine they would listen into it in segments. That's probably what I'd recommend.
Yeah. I think I'd probably support that too. All right. Awesome, man. Hopefully we'll get to, come back and have a chat sometime soon.
Sounds good.
Cheers, mate.
Thank you.
Thanks for listening. If you want to see more from William, check out his YouTube channel via the link in the episode's description. If you want to get in touch with me, I'm on Twitter at critical_coach, on Facebook at the critical coach, or one word, and on Instagram as the _critical_coach. Cheers.